to forecast time series with robust exponential smoothing methods that have a trend and seasonality. So the package is called RobETS, which stands for Robust ETS. So, and what we will be doing is forecasting univariate time series. And usually this will be rather short time series, like for example this one. This is the monthly number of unemployed people in Australia. And we want to predict this time series. Okay, and we want to be able to, well, okay. So we have several questions if we see this time series. So is there additive or multiplicative noise? So that means, does the noise scale with the time series or not? Is there a trend in this time series? Well, we could see that sometimes there is a temporary downward trend and then a sudden shock that goes above and then it goes downward again. So there might be some trend in this time series. And there also might be seasonality in this time series because it's a monthly time series. So in January there might be more unemployment for some reason. And this seasonality can also be additive or multiplicative. So that means that this seasonality can scale with the level of the time series, or it can be that it cannot, that it does not. Okay, and there exists already a method to forecast time series that have this additive noise, this multiplicative noise, and so on. And it's the ETS function of the forecast package of Heinzmann. So he implemented an exponential smoothing method where he estimates 15 different exponential smoothing models that of which some of which have a trend, others don't, and some of which have seasonal components and others don't. And then this ETS function estimates all those models, and it computes a selection criterion, an AIC criterion, and then it chooses the model with the lowest AIC, and the forecast of that model is then used as a real forecast, as the forecast. And you can see that ETS selects here a model with multiplicative errors, a damp trend, we will later on see what it is, and multiplicative seasonality. So what this function does is basically automatic forecasting. Okay, so this is very nice. But what about time series like this one? So what we see here is a time series that goes up a little, so there might be a trend. It's a quarterly time series, but seemingly there is no seasonality. But at the end of the time series, there is something weird happening. There is, kind of unexpected observation. So what do we do with this observation? Okay, well, we can see what ETS does. What it does, it gives a lot of importance to this last observation. So you can see that the forecast of the time series is between this weird observation and the original level of the time series. Well, we developed a method, RobETS, so robust ETS, that gives less importance to these outlying observations. Okay, so you can see that the forecast is way closer to the original level of the time series and doesn't depend that much on the outlier. What we also can see is that ETS selects a very simple model, so a model with multiplicative errors, no trends, and no seasonality, whereas robust ETS discovers a trend and multiplicative seasonality. Okay, and as you can see, so the function ETS is very easy to use. You just you just supply the time series and you get basically a forecast back. And Rob ETS is can be used in entirely the same way. Okay, so how does this method work? So let me first explain what is exponential smoothing. Okay, so an exponential smoothing is basically a forecasting equation like this one. This is the most basic, most basic exponential smoothing, and it's called simple exponential smoothing. And it has it forecasts a constant. It gives a constant forecast. Okay, and it depends on one parameter alpha. Okay, and what happens in ETS is they don't only use this exponential smoothing, the simple exponential smoothing method, but they expand it with a trend, which is then called Holt Winters, and also a seasonal component. Okay. So one of these models, this is a model with additive damped trend and multiplicative seasonality. Well, one of these forecasting equations looks like this. So we see that on top of the level with the smoothing parameter alpha, we also have a trend, BT, and a seasonal component, ST. And because we have this extra trend and seasonal component, we need to estimate more parameters, also this beta, this phi here, and this gamma. So we will need to estimate these parameters later on somehow. Okay. But if you know these parameters, you can do a forecast. And just as an illustration, I made the forecast for a few of these models here. So here in blue, you can see the forecast of a model with multiplicative errors and multiplicative seasonality, but no trend. Then in green with a damped trend, and then in red with a full trend. And you can see that seasonality is multiplicative here because indeed this forecast scale, the seasonality effect scales a bit with the level of the forecast. I mean that the seasonality effect gets smaller. Okay, but so for this time series, ETS chose the green forecast. Okay, and how did it choose? So it's estimated all these models, so all these different combinations. It estimates the parameters. It computes the AICC, which is a selection criterion that penalizes if the model has a lot of parameters, and then it selects the model with the lowest AICC, which was in, yeah. Okay, so this is, so far I explained ETS. Well, Rob ETS will work in entirely the same way, but what we do is we make every step of the process, we make it outlier robust. So that means that one observation can't influence the forecast too much. Okay, so the parameter estimation step, we robustify it, and also the forecasting equations we saw earlier. And also the selection criterion needs to be robustified. Okay, so why is ETS not robust? Well, we can see here in the forecasting equations of one such model that the level and the seasonality linearly depend on previous observations. So also the forecast linearly depends on previous observations. So if one forecast, one observation is very large, well then subsequent forecasts are heavily influenced. Okay, so and what we do as a solution is we replace the observations by some kind of cleaned observations. So we replace the yt's by y stars, and these cleaned observations are most of the time just equal to the original observation, unless that that the observation is more than 3 standard deviations away from the prediction. Okay. So we kind of bound the cleaned observations between two bounds. Yeah. Okay, so this is how we robustify the forecasting equations, but we also need to estimate parameters. So the smoothing parameters that I talked earlier about. Okay, and that we do by replacing the original maximum likelihood estimator and the ETS function by a robustified maximum likelihood estimator. So here I give an example for the additive error model, but I also did it for the multiplicative error model, but in a different way. If you want to know how, I can explain later if you want to. So we also robustified the selection criterion, and that's very simple. We just replace the likelihood in the AICC by the robust likelihoods that we proposed. Okay, so then we did some simulations. So basically we generated time series like the left one and like the right one, and we saw which methods performed best, ETS or ROP ETS, and it's no surprise that ROP ETS indeed gives better forecasts if there are a lot of outliers. So I also want to show you some real data examples. For example, this is the time series we saw earlier, so with a huge drop here. So we can see that ETS gives a lot of importance to this special observation, whereas ROP ETS doesn't, and indeed in this case the forecast is better. So ROP ETS can also detect outliers. So here the outliers are highlighted with a red dot. Okay, and here is another example. Someone asked on Stack Exchange, yeah, I used the ETS method, okay, and my forecasts are a bit unexpected, okay. They are way higher than I expect them to be. Well, and that's because there is an outlier in this time series. Apparently this last point here is an outlier, because you see here you have each time a very low value, but then at this time it's not as low as usually in that season. So that's why there is an outlier. And that could have been detected with the function plot outliers, and then of the ROP ETS package, and then you can see indeed that this last observation is highlighted as an outlier. Okay, thank you for your time. These are here I compare the computing time of ROP ETS, and it's not that much slower than the than ETS. Okay, thank you.
We have 3 minutes time for questions. The outliers are removed from the computation, or you are estimating?
The what? No, the outliers are not removed. No, I basically have a time series with outliers, and then I estimate it with a robust method, so that there is less importance given to these outliers. Yeah. Yes.
Speaking of robustness, how does the package handle if you're missing values?
It doesn't.
So that does happen for time series. Last time you got out.
Yeah, yeah, yeah. Okay.
More questions? If not, then we would like to thank Ruben again.
Okay. Thank you.